We know that the electrons for covalent bonding come from the valence electrons. We also know that we can tell how many electrons or how many valence electrons a given main group atom has by looking at its group number. Here on this slide, we see a simple, effective way of representing number of valence electrons known as Lewis dots. And group 1A has 1 valence electron, so there's 1 dot. Group 6A, 6 valence electrons, 6 dots. So I just want to point out some important features of how to draw the dots. The dots are equal to the number of valence electrons, which we find by looking at the group number for the main group elements, except for helium, which is in family 8A, but it only has 2 valence electrons. When we draw these dots, we draw them in the 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock position. And we don't pair them until we have to. So if we look at group 4A, there are 4 electrons in the 12, 3, 6, 9 o'clock position. And then once we get to 5 valence electrons, we have to start pairing them. Now, it doesn't matter if we pair the 12 o'clock or the 3 o'clock or the 6 o'clock or the 9 o'clock position. It doesn't matter where we pair, but we leave them unpaired, meaning single dots, until we have to. Now, when we draw our Lewis dot structures for atoms, that can help us figure out how covalent bonding occurs. So let's look at this example of figuring out the simplest molecule between carbon and hydrogen. And here is our Lewis dot for carbon. It's in family 4A, so 4 valence electrons, and hydrogen, family 1A, so 1 valence electron. Now, when we draw these simple molecules, there will always be one central atom, and that central atom is the atom that has the capacity to form the most bonds. So we look at hydrogen, it only has 1 electron. It can only ever form 1 bond. Hydrogen will never, ever be the central atom because it can only form 1 bond. Carbon, on the other hand, has 4 unpaired electrons, and each one of those unpaired electrons wants to be paired. So carbon has the capacity to form 4 bonds. So however many unpaired electrons you have at this phase, that's how many bonds you can form. So carbon can accommodate 4 hydrogen because each hydrogen can donate 1 electron. Each carbon has 4 unpaired electrons. And here is the Lewis dot structure for the simplest carbon-hydrogen compound known as methane. And one thing that this Lewis dot structure represents is the octet rule, which states that many main group elements want to gain an octet of electrons because that is the number of valence electrons that the very stable elements in group 8A have, that filled shell, if you remember. So carbon, nitrogen, oxygen, and fluorine always follow the octet rule. Hydrogen can never follow the octet rule. It can only accept 2 electrons. So once hydrogen has 2 electrons, like helium, it's happy. Carbon will always react in such a way so that it has 8 total valence electrons.